Okay, hey guys, hope you're being good for the sub. Get your notes that say acids and bases. You should have got two note sheets when you walked in first. We'll take a break in between them. I'm making two separate videos, but just be ready to go. All right. Both the videos are 15 minutes. They're not terribly long. You'll have a worksheet to practice everything we learned today on after those videos, and you have a quiz on Thursday, which you can use all your notes. So pay attention. All right, let's get started. Okay, we're talking about acids and bases. You should have watched that Tyler DeWitt video to kind of give you an intro. You've heard of acids and bases, so I will go kind of quick. My notes will be posted on my website, and if you get behind. So, what do we know about acids? We know they taste sour. We know that aqueous solutions, that means water-based, are electrolytes. That means they conduct electricity or create or complete a circuit. We know that acids cause indicators to change colors. You remember litmus paper maybe from like elementary school or junior high? We're going to do it again. We know that acids, many metals react with acids to make hydrogen gas. We know that acids react with bases to form a salt and a water. I would underline star that. That's probably a test question. When an acid reacts with a base or a base reacts with an acid, your products are always a salt, not necessarily sodium chloride, but an ionic compound and water. And another one important, most formulas for acids begin with H. Our next set of notes is going to be on naming acids and bases. So most formulas for acids begin with the H. Let's move on to bases. All right, bases are bitter. They taste bitter. Like an example of a base would be soap, or even like if you've ever had unsweetened chocolate, like not dark chocolate, but like unsweet chocolate. It's really gross. Bases are electrolytes also in aqueous solutions. Bases also cause indicators to change colors, just not the same color that an acid would turn an indicator. Bases are slippery. Again, soap is a classic example of a base. That's probably a quiz question, okay? Um, and again, bases react with acids to form a salt and water. And when we're naming bases, they often have almost always have OH or hydroxide in the formula. The one exception is ammonia is NH3. You just need to memorize that one. We're going to talk about that again. Okay, I'm going to pause for like 10 seconds if you need to catch up. Okay, let's move on. So just some examples of acids and bases. I know they're all formulas, but just like we said, most acids have begin with H, hydrogen, in their formula. Pretty much every acid that we're, for our purposes, we can say every acid. Bases almost always end, or their anion is OH hydroxide. The one exception is NH3 is ammonia. You just, like I said, memorize it. Okay, it's the exception to the rule for naming, and that is again our next topic. Okay, you hopefully have seen the pH scale before. I would even like maybe have the sub pause this, and you don't need to write down all the examples, but make sure you have a pH scale that's labeled from 0 to 14. All right. And in a nutshell, we know that if a pH is under 7, it's an acid. If a pH is above 7, it's a base. But let's talk about it in a little more detail. All right. It says that your notes say that the pH of a substance can tell us if it's an acid, a base, or neutral. pH is a measurement of the concentration of hydrogen ions in a solution. The more hydrogen ions there are, the more acidic a substance is. So down here, the pH of 0 or 1, that's super acidic. And the example is gastric acid, that's stomach acid. That's how your food all gets digested. So that means it's got a really high hydrogen ion content. Acids have large amounts of hydrogen ions and a low pH, below 7. Okay, you can see the example at 7 is distilled water. It's like neutral. 7 is neutral. These are all acids. If you go up, these are all bases. You need to know that. You might write a real brief sketch in your notes. And then everything with acids and bases are kind of opposites. So acids have a large amount of hydrogen ions and a low pH. Bases have a small amount of hydrogen ions and a high pH above 7. Okay. Another measurement besides pH is pOH, or hydroxides. OH is hydroxide. That tells us the concentration of hydroxide ions in solution. the more hydroxide ions present, the more basic a substance is. So the closer you are to 14, going away from neutral 7, the closer you are to 14, the more basic it is, the stronger base it is, and the more hydroxide ions you're going to have in solution. So acids have a small amount of hydroxide ions and a high pH. Bases have a large amount of hydroxide ions and a low pH. Again, always opposites. Neutral substances have equal amounts of hydrogen and hydroxide. There's some typos in here, ions. Neutral substances have equal amounts of hydrogen, and this should say hydroxide ions. So their pH is 7 and their pOH is also 7, because I would also star this. You're going to have to know that for sure. If you to add up the pH and the pOH, you should always get 14. Okay, and we'll practice that in a minute. So here you go, you've got your pH scale. Like, that's the one we're more familiar with. We know 7 is neutral. We know below 7 is acid. The closer you are to 0, the stronger the acid is, the stronger your hydrogen concentration. Okay, again on the pH scale, above 7 is a base, and the larger the number, the closer to 14 you are, the stronger the base. The pOH is just opposite. It's your concentration of hydroxide ions. The pOH scale, under 7 is a base, and above 7 is an acid. So again, if you can just remember this one that you've probably known since elementary school, everything is just opposite on the pOH scale. I'll give you a minute if you want to take a quick note on that. Or take a picture, maybe. You might take a picture of that, actually. It might help you. I'll give you a second. These PowerPoints will be posted on my website also. 5, 4, 3, 2, 1. I'm moving on. Okay, so let's just practice what we learned real quick. Okay, if I have a pH of 5.6, is that an acid or a base or neutral? Hopefully you remembered if it's below 7, it's an acid. Okay, NH3, is that an acid, base, or neutral? Anyone? It is a base, and that's the one I said you just have to memorize. It doesn't have hydroxide in the formula. You just have to know that NH3 is ammonia and it's a base. All right, large concentration of ions, acid or base? It's a base. We said large concentration of hydrogen ions is an acid. A large concentration of hydroxide ions is a base. So if you have a small concentration of hydrogen ions, are you acid, base, neutral? Anyone? Okay. You would also be a base here because a base has a high hydroxide concentration and therefore a low hydrogen concentration. Okay, pOH of 3.2. Now, I even have trouble remembering this sometimes, but I've known since elementary school that a pH, not pOH, but a pH below 7 is an acid, and everything's opposite with the pOH scale. So that would mean that if a pOH is below 7, then it's going to be a base. I hope that made sense, but like that picture I told you to take, or that scale I told you to take a picture of, explains that again, all right? If your pH equals your pOH, we talked about that just a minute ago, that means they would both have to be 7 because they should always equal 14. So if they're equal, that's your key or your sign that you're talking about a neutral solution. Okay, H2SO4. H is your hint here. We said in our notes that if you have, if it starts with an H, it's going to be an acid. If you have a formula that starts with an H or hydrogen, it's going to be an acid. And on that same note, we said if your formula has OH, hydroxide, it's going to be a base. Down here, large concentration of hydrogen ions. What is it, acid or base? It's an acid. And last but not least, is this formula for an acid or a base? This is your hint. If it starts with H, it's going to be an acid. Okay, I know I'm going kind of quick on that. Um, that was just practice. You're also going to get a worksheet to practice, and everything that we just did was in your notes. Okay, so we're going to move on so I don't run out of time. Okay, little quick math. You do not need a calculator, I hope. All right, if the pH, it says if the pH of a solution is 6, what is its pOH? Remember that pH plus pOH is always equal to what? Yes, 14. So if pH is 6, all right, 14 take away 6, my pOH must be 8. That makes sense? And, okay, go back to that scale. Is that an acid or a base? pOH is 8. Is that an acid or a base? Hopefully you know that that's going to be an acid. Okay. Number 2, if the pH of a solution is 4, what is the pOH? Okay. Remember, they always add up to 14. So 14 take away 4 is 10. Okay. And it's pretty close to 8 for pOH. So again, it's going to be an acid. If you check that scale, above 7 on a pOH scale is an acid. It describes an acid. Last but not least, we've got a pOH of 3. What is its pH? Again, they always add up to 14. So 14 take away 3 is 11. And it's 11 is the pH. So think about it. Is that an acid or a base? On a pH scale, anything above 7 is a base. Yes. Okay. Good. Easy peasy. Takeaway is pH plus pOH is always equal to 14. Okay. And last but not least, indicators. We're going to do some labs on Thursday. So after the quiz, they're fun. All right. You use indicators all the time. My husband has a chemistry set for our pool. He's always putting little drops in and they're turning colors to tell him if he needs to add something. Those are indicators. You use indicators in life. When you take a drug test, it's an indicator. If you take a pregnancy test, it's an indicator. So we use these. I'm trying to think of another example, but those are pretty classic ones. So, okay, indicators are substances that change color in solutions of different pH, and they give us an approximate pH. At least they'll tell us if it's acidic, neutral, or basic, okay? So the first indicator that you need to know is phenolphthalein, okay? And you need to know, just memorize it. If you put phenolphthalein or put a drop of a substance in phenolphthalein and it is colorless or clear, that means it's an acid. If the indicator phenolphthalein turns pink, it's a base, okay? Just memorize that. Phenolphthalein is clear or colorless in an acid and pink in a base. Next up is universal indicator. These are fun. All right, you get the whole rainbow of colors, so you get them. You don't just find out if it's an acid or a base. You get a little more detailed approximate pH. So starting with very acidic is going to be orange, slightly acidic. You know, orange to red to yellow. Green is neutral. So all these colors here are acidic. Green is neutral, and then your darker colors, your blues and your indigos are going to be your bases. And like I said, we're going to do all these in the lab soon, so it's kind of fun to see. And is that it? One more, I think. Litmus paper, good old litmus paper. You've probably used that since elementary school. Litmus paper, you need to know, turns blue in a base. And, oh, well, okay, take it back. It depends on what kind of litmus paper you have. I always used red as a kid, but there is blue litmus paper and there's red litmus paper. Blue litmus paper turns red in acid, and red litmus paper turns blue in a base. Okay, so opposites if you can remember that. Blue litmus paper turns red in an acid, and red litmus paper turns blue in a base. Okay. Again, you have a quiz on Thursday. You get to use your notes, so make sure you took them. They will be posted on my website if I went fast or if you got lost. That's it. Thanks, guys.